All right, this lecture is going to show you how to balance a redox reaction. Now, balancing a redox reaction can be simple, like a single replacement reaction, but in this section, we're looking at much more difficult reactions to balance. And in order to balance a redox reaction, you need to go through a series of steps. Now, the nice thing is once you get these steps down, you can simply apply it to any redox reaction over and over and over again. So much like stoichiometry, once you get the process down, it's fairly simple to go ahead and balance, all right? So the first thing we want to do is split a reaction, okay, into two different half reactions. Okay, so to go through these steps, I'm going to follow it by going through an example. So the first one there is number 2. Okay, we're looking here at the chromium reaction. What I always do is I look at the products, sometimes even just the reactants, but what I want is I'm going to have one of the reactants go to one of the products and the other reactants go to the other one. So the first half reaction, because I'm going to split this in half, is I'm going to see what substances go ahead to form the precipitate chromium sulfide. And obviously we don't want the chlorine in here because there's no way of balancing chlorine if it isn't part of it. So I'm going to have the chromium ions and the sulfide ions. Okay? And I like to you got to leave room because you're going to add stuff to either side of these reactions to balance them. Which means in the other half reaction will be the chloride ions coming together to form the chlorine gas. All right, to balance redox reactions, the first step is once we've broken the half reactions, is we want to balance all of the atoms, except hydrogen and oxygen. So balance all other elements other than hydrogen and oxygen. So we're just going to balance the atoms. We are not worried about the charge yet, okay? So don't look at the +3 or the -2 on the sulfur or the chromium. So there's one chromium and there's one chromium. There's one sulfur, there's one sulfur. If there were oxygen in this chemical compound, we would then balance oxygen by using water molecules. We don't need to because there's no oxygen. Then we balance hydrogen using hydrogen ions. If there's no hydrogen, same thing in this case, we don't have to worry about it. Skip it. The last thing we need to do is to balance the charge, and this is where most students screw up, okay? You've got to be able to summate the charge, the sum of all the oxidation numbers on both sides of the reaction. So on the left side, you'll notice that we have a +3 and a -2, okay? So +3 and -2, that's summate to +1. So it's a charge of +1 on the left. On the right side, you'll notice that there's no charge in the chromium sulfide. Therefore, it's a 0. So we have +1 on the left and 0 on the right. The side that is more positive, we need to add electrons, which are negatively charged, to balance the reaction out. So since it's a +1, I would need to add one more electron because then the -1 on the electron and the +1 would cancel, leaving us 0 on both sides. So that tells me I need to add an electron to this half reaction. And doing so now, I've got +3, -2, and -1, and that summates to 0. So now we're balanced in charge, and we're also balanced in atoms. So right there is an example of the first half reaction being balanced. Now one little side note, you'll notice that the electron is on the reactant side. If the electron is on the reactant side, this tells me that this is a reduction reaction. Reactant side, reduction, okay, RR, reactant side, reduction. So whatever side the electrons are on, okay, if it's on the reactant side, it's the reduction. This is called the reduction half reaction because it's not the full reaction, it's just half of it. But this is a reduction half reaction. Okay, the second reaction, immediately we should end up having electrons on the other side because again, reduction, we're gaining electrons, we're adding electrons. The other half reaction has to be opposite. This better end up being the oxidation half reaction because we can't have both half reactions being reduction. All right, so now on this side, you'll notice that there's 2 chlorines on the right and there's 1 on the left. So I need to put a 2 out in front of the chlorine. Doing that causes me now to have 2 chlorines on each side, so now I'm balanced. Okay, 2 times -1, we got a coefficient, we have to make sure to apply that. So there's 2 -1, so that's a total of -2. And on the right side, it's 0. So the more positive side now is the 0. The more positive side is the side that we have to add electrons to. How many electrons do I need? I need to make 0 become -2. So that tells me I've got to add 2 electrons. Okay. So I'll erase those off of there. So now if you look at this, now my overall reactions are balanced in the fact that I got 2 chlorines on each side and I've got now -2 on the left. 0 plus -2 gives me -2 on the right. Now I'm balanced. So now both of my half reactions are balanced. The last step now is to make sure that the number of electrons transferred are the same in both reactions. Well, you'll notice that there's 2 electrons on the right for the oxidation, but there's only 1 electron on the left. We have to make sure that the number of electrons transferred is the same. So how do I do that? I have to now come back and I have to multiply this top reaction by 2. So I multiply everything by 2. I double all of it, leaving 2 chromium plus 3 plus 2 sulfides plus 2 electrons produces 2 chromium sulfide. Okay, now this reaction is no longer present. So now I have 2 electrons on the right side and 2 electrons on the left side, which now means my last step now is to summate these 2 reactions together. So I'm going to add them together. All right, now because there's 2 electrons on the right and 2 on the left, they are going to cancel out because we're going to end up having 2 electrons on the left and 2 on the right, and therefore through algebra they would cancel out. So anything that's on either side of the reaction can cancel if you have the same number of them. Okay, so what I'm left with now is 2 chlorine plus 2 chromiums plus 2 sulfides produces chlorine 2 . Okay. Now, if I've done this correctly, there should be no electrons present in the overall equation. There's a transfer of electrons, but because it's balanced, they cancel out. When I'm done, this reaction needs to be balanced in atoms, and it needs to be balanced in charge. You need to check both of these, okay? So now if I look back through and check, there's 2 chlorine on the left, there's 2 on the right. There's 2 chromiums on the left, there are 2 on the right. There's 2 sulfurs on the left, there's 2 on the right. My atoms are balanced, check mark. I'm done with checking the balanced atoms. The last one that most of my students don't do an effectively job is they have to look at the charges as well. We have -2 because there's 2 chloride ions, so that adds up to -2. There's 2 chromium ions, each one is +3, so 2 times +3 is +6. And 2 times -2 gives me -4. So if I add this up, -2 plus 6 and -4 add up to 0. On the right side, the chlorine is 0 and the chromium sulfide is 0. Does 0 equal 0? Yes, both sides equal 0. We're balanced in charge as well. The reaction right there is the net ionic reaction for this redox reaction. And that's how we do them, okay? All right, let's try another one. Look at permanganate and manganese, iron and iron, okay? First thing you'll notice is acidic solution, so we're going to balance this reaction acidically. So today, that's what we're going to look at, is we're just going to follow the steps to do acidic reactions, and I have a homework problem for you. The basic ones will be then the next lecture, and I'll show you how to do basic, which literally is to do the acidic reaction first and then do one additional step, okay? But that'll be for another lecture. So to balance acidic reaction, we're going to follow the same steps we just talked about, okay, up above. First thing you want to do is split this into 2 half reactions. So that's pretty darn easy to do that when all you have is two elements on each side, or say two compounds on each side. We have permanganate on the left. Who is that going to be attached to on the right side? Is the permanganate going to become iron, or is the permanganate going to become manganese? Hopefully it's not too hard. We want to identify like elements, and that ends up being the half reaction we're going to work off of. And then we have iron plus 2 becoming iron plus 3. So the first challenge is to figure out the half reactions. Okay, all right, next step. Balance the atoms other than hydrogen, oxygen first. So for the first reaction, the permanganate reaction, we're not going to look at oxygen. We're just going to look at the manganese first. So how many manganese do I have on the left? Just one. How many on the right? Just one. Okay, the charge does not indicate the number of manganese. Okay, so there's one on each side. So we're balanced in manganese. So the next substance is oxygen. Well, if I go up here, how do I balance oxygen? I balance oxygen by adding water molecules. I'm going to add water to the side that there's less oxygen. So there's no oxygen on the right side. The only way I can balance it is by creating or putting down a substance that would be on the right side of the reaction. Now remember what the title of this unit is. The title of this unit is aqueous solution chemistry. So all of these chemical reactions are occurring in water, and therefore water is always present. So water can always be placed in these redox reactions as a way to balance the oxygen. Either side of the reaction. You could add water to the right side, you could add it to the left. It doesn't really make a bit of difference. So there's 4 oxygen atoms on the left. So to get 4 on the right, I need to put a 4 out in front. Okay? Now that adds a new dilemma. So right now I'm balanced in both manganese and oxygens, but now I have hydrogens to worry about. How do I balance hydrogens? If I look at the top, the next step is we balance hydrogen by adding H plus ions. So again, I'm going to add H plus to the side that has not enough hydrogen. And to balance 8 hydrogens, I need 8 hydrogen ions. Okay? And again, H plus hydrogen ions is acidity. That's what makes something acidic, is by having protons, hydrogen ions. So because this is an acidic solution, hydrogen ions are prevalent and therefore can be placed on either side of the reaction to balance the half reactions. All right, now we are balancing atoms. We have 1 manganese on each side, we have 4 oxygens on each side, and we have 8 hydrogens on each side. The last thing to balance is charge for this half reaction. Okay, on the left side, okay, I'm going to do this over here in the corner here. On the left side, I've got -1 for manganese. I've got a +1 on the hydrogen, but be careful, there's an 8 out in front of it. So it's like having 8 plus 1 hydrogen, so that's +8. Okay? On the right side, I have +2 with the manganese, and there's no charge on the water, so that's 0. So -1 and +8 add to +7. So there's +7 on the left, and there's +2 on the right. So what side is the most positive? +7 is more positive than +2. So I have to add now a certain number of electrons. How many electrons do I have to add to balance this reaction? Hopefully you said 5, because 5 electrons added to +7 is going to give me -2. Excuse me, +2, not -2, +2. +7 minus 5 is +2, and it's still +2 on the left side. So that tells me I need 5 electrons on the left side. Okay, so now just to recap and check, I've got -1 with the permanganate, I got -5 with the 5 electrons, that gives me -6, +8 with the 8 hydrogens, -6 and +8 give me +2, and that's balanced by the +2 on the manganese. We're good. All right, the next reaction, okay, we have 1 iron and 1 iron. Since we have no oxygen, we don't have to worry about adding water. We don't have any hydrogens. We don't have to worry about adding hydrogens. We can jump right into adding electrons. So we have +2 on the left and we have +3 on the right. Which side is the more positive side? The right side is more positive. How many electrons do I have to add? If I add just one more electron, that makes both sides be +2, and now I'm balanced. Okay, so now we have our two half reactions balanced. Okay, however, to add the reactions together, the number of electrons have to be the same on both sides of the reaction. Okay, so in order to do that, I now have to make there be 5 electrons on both sides because there's 5 in the top. I can easily get 5 on the right by multiplying the bottom reaction by 5. Okay, so I'm going to rewrite the reactions. When you are done, both half reactions should have the same number of electrons, and they have to be on opposite sides. If you end up having both half reactions have electrons on the same side, you've done something wrong. You've done something with your math. There has to be electrons on your side. Now, what would the top reaction be? Would the top reaction be a reduction half reaction or an oxidation half reaction? If the electrons are on the reactant side, it's what? Reactant side is reduction, which means the other reaction, because it's on the product side, is oxidation. Okay? All right, so now we're going to add up these reactions together. So the electrons will get eliminated because I have 5 on the left and 5 on the right, so that will cancel. And then I just add up the rest of this. Okay. And right there is my answer. There's my balanced redox reaction. These are not as simple as just simply add 2 to the left, 2 to the right, and it's going to balance. There's a lot more steps to them. I like the challenge of them. They require a lot of math, and it's very easy to make one little mistake wrong. But once you kind of get the hang of them, they're kind of fun because it's a challenging thing that if you follow the process, you can easily get. Okay? So with that, again, when you're done, you should check the reaction to see that it is indeed balanced. So let's do that real quickly. 1 manganese, 4 oxygens. 4 times 1 is 4 oxygens. 8 hydrogens. 4 times 2 is 8 hydrogens. Ooh, I forgot. That's why we always check. I forgot a 5 over here. There should be 5 Fe plus 2. I forgot that easy 5 there. Again, very easy to make a mistake. Should be a 5 in front of the iron 2, so there's 5 irons on both sides. Last thing to check is we want to check charges. So the manganese, there's only one of them. It's -1. There's 8 hydrogens, so that's +8 because there's 8 positive ones. And 5 times 2, and it's +10. So the summation of all those charges add up to +17. On the right side, there's 1 manganese for +2. The water is electrically neutral. And 5 times +3 gives me +15. That adds up to +17. The charge is also balanced. The charges do not have to be 0 and 0 on each side. We have +17 on the left, +17 on the right. This reaction is overall balanced. So that is how we do redox reactions for acidic reactions. And when you're done, you'll typically have hydrogen ions on either the reactant or product side, but the presence of the hydrogen ions indicates that it's an acidic solution. And that's how we balance those reactions. So I have 5 problems, 5 redox reactions I'd like you to try to balance with their solutions online. I'd like you to give them a try. And if you have any questions or problems, I'll be glad to go over a problem with you step by step, face to face. Just let me know and give me a call or send me an email and we'll plan a time. Thanks for listening.